I'm Dean Gesh. I'm a research physical scientist working for the U.S. Geological Survey. Well, the project in Ponape is a big collaborative project with U.S. government agencies and then also groups in the Federated States of Micronesia, looking at the resiliency of the mangrove forests, how they will fare in the face of climate change, specifically sea level rise. It is a hope that what's learned here can then be applied to other islands, both within the Federated States of Micronesia and also other islands in the Pacific that have mangrove forest. It's a high relief island. Ponape is. They're volcanic in origin, so it has a high relief. But the coastal mangrove forests that ring the shoreline, that's why they're called fringing, stand out. They look different. There's a different shade of green, if you will, if you're flying in, and when you see it on photography, it's a low relief environment, meaning it's right at sea level. So that's where a lot of the direct impacts of climate change, specifically sea level rise, are noticed. Because it's a low relief environment, elevation change of just a few inches across the extent of the forest can mean a lot of different things. So to measure elevation that precisely, the most effective way to do that is to use surveying techniques, ground surveying, elevation. So we establish a very accurate elevation outside the forest canopy. So GPS allows us to do that. And then from that point, we use differential leveling to extend the accuracy of those elevations into the forest. The tide comes and goes, so at certain times you're standing in water up to knee level or sometimes even up to waist level. When the tide is out, you're standing on saturated ground or mud, so it's a challenging environment to work in, but you can still measure those elevations. It's solid ground that you're standing on. Coastal mangrove forests are very important in a lot of ways. They have what we call a lot of ecosystem services. So they provide protection from coastal storms. They absorb a lot of the energy and waves and wind that comes off the ocean. They store a lot of carbon, so what we call carbon sequestration. They provide nurseries for sea life, for animal life that's in the coastline along those forests. On the human side, they provide wood products for fuel and building materials and that sort of thing. But as the sea level rises, the forests need to keep up with that, if you will. If you have an adequate sediment supply, that forest floor will build in elevation and can, in a sense, migrate. The term we use is migrate inland, but that needs open land to accommodate that inland migration as the water goes up. So one of the uses of this type of information is to identify those areas just inland of the mangrove forest where, as a response to sea level rise, the mangrove forest can migrate inland. And then they can work to preserve that land and make it available for the natural migration of the mangrove forest inland. And there's a real big push in the project to apply this information on a very local scale. So there'll be community outreach from the Conservation Society of Ponape, one of our major project partners, and they will work to apply this information in the management and conservation of the mangroves, and also in an educational sense to the local communities to teach the importance of the mangroves and preservation and good conservation of the mangrove forests.